Hello friends, welcome back to my YouTube channel. So in today's video we'll solve the one more problem of slope deflection method. So this is the given beam. It is having the span A to B is the point load which is not at the center, and from B to C is the another span having the point load which is acting at the center, and span C to D is the having the UDL of 20 kN. So this is the given problem. So in slope deflection method, the first step is to find out the fixed end moment. First step is to find out the fixed end moment of span A, B, B, A, C, B, C, D, etc. So we'll see. We'll see the fixed end moment for span AB. So MF AB is equal to, for this span we'll see the fixed end moment for span AB. So span AB, the load is not acting at the center. So for this we have the formula. See here also the load is not acting at the center. We have the formula to find out the MFAB, that is minus WAB square divided by L square, and MFBA, from B to A we have the formula WA square B divided by L square. By using these two formula we will calculate the fixed end moment for AB as well as BA. So now we will see. So formula is minus WAB square divided by L square. Because it is acting anti-clockwise, the load is 20. So load is 10 kilonewton. Load is 10 kilonewton. A is, this is A. From here to here is A, here to here is B. So A value is 1, B is 2. 2 square divided by span. Total length is 3 meter. 3 square. By simplifying it will come out as minus 4.44 kilonewton meter. Similarly for span BA. So MF BA, we have the formula WA square B divided by L square. So load is 10, A is 1 square plus B is 2. B is 2 divided by L is 3 square. So simplifying it will come out as 2.22 kilonewton meter. 2.22 kilonewton per meter. So similarly we'll calculate this for span BC. So for BC the load is acting at the center. For this we have the formula. The load is which is acting at the center. We have the formula MFAB is equal to minus WL divided by 8 and MFBA is equal to WL divided by 8. By using these two formula we'll calculate the fixed end moment for span BC as well as CB. So now we'll see for span BC. For span BC, MFBC is equal to, we have the formula minus WL divided by 8. So minus load is 20, L is 4, 2 plus 2 4 divided by 8. By simplifying it will come out as minus 10 kilonewton meter. Similarly for MFCB, the formula is same, only the sign will change here negative, here positive. So answer will come positive, that is 10 kilonewton meter. So now we'll go for the span CD. So it is having the UDL. MFDC is equal to, for UDL we have the formula MFAB is equal to minus WL square divided by 12 and MFBA is equal to WL square divided by 12. By using this formula we will calculate the UDL for span CD. So MFCD is equal to, we have the formula minus WL square divided by 12 minus W is 20, load is 20, our span is 4, length is 4 square divided by 12. So it will come out as minus 26.6 kilonewton meter. So for MFDC we have the formula WL square divided by 12. the here only the formula is same, only sign will change. So it means the answer will come in positive 26.6 kilonewton meter. So this is how we calculate the fixed end moment for span AB, BA, BC, CD and CD, DC. So this is our first step. Now we have moved to the second step. Our second step is to calculation of the slope deflection equation for each span. So by using the formula, these two formula, that is MAB and MBA is equal to this formula. By using these two formula, we'll calculate the slope deflection equation. So now we'll see. Step 2 is applying the slope deflection equation for span AB. So for span AB, we'll calculate now. So MAB, we have the formula MAB is equal to this formula. So I will write here. So the formula is this one. MAB is equal to MFAB plus 2EI divided by L 2 theta A plus theta B minus 3 delta divided by L. So this is the formula. So by using this formula, we'll calculate the MAB. So now our MFAB we got was minus 4.44. So substitute minus 4.44 plus 2 EI is constant, the value is not given. L is 3 meter. L is 3 and 2 into theta A is fixed end. At fixed end our slope is 0. So as I told you, at fixed theta is 0. So here 2 into 0 becomes 0 and plus theta B. So theta B, the hinged support have the some value. Our hinged support have the some value. Theta is not equal to 0 here. So it means here it will come some value. Again the sink value is not given, deflection value, it becomes 0. So now MAB is equal to minus 4.44 plus 2 EI theta B divided by 3. So call it as equation number 1. So this is the equation number 1. So similarly for span MBA, so for MBA we have the formula. We have to use this formula. MBA is equal to this. I will write here. So MBA is equal to, we have to use this formula. So MFBA plus 2 EI divided by L 2 theta B plus theta A minus 3 delta divided by L. So substitute all the value. So MFBA we got was 2.22. So substitute that value 2.22 plus 2 EI is constant divided by our span BA value is, so span BA is 3 meter. 3 2 into theta, here theta is the hinged support B. At point B is hinged support, it means it has some value. So keep it as theta B. So theta A is fixed end, so value is 0. Again the deflection value is not given, it becomes 0. So simplify this. MBA is equal to 2.22 plus 2 into 2 4 EI theta B divided by 3. Call it as equation number 2. So similarly we have to calculate the for span BC and CB. So apply slope deflection method for span BC. So now MBC is equal to, for that we have the formula, this formula. Only here alphabet will change. The formula is same. So I will show. In case of A, we need to substitute B. In case of C, we need to put C. So now we'll see. So MBC is equal to, I will write here, MFBC plus 2EI divided by L 2 theta B plus theta C minus 3 delta L. So our MFBC value we got was, so we got minus 10. So now substitute that value, minus 10 plus 2EI divided by L value is 4. So our span is 4. 2 into theta B has some value because it has the hinge support, and plus theta C is also, it has the hinge support here. Theta B and theta C has the hinge support. It means the theta value will not equal to 0 at hinge support. Some value will come here. So again it becomes 0. So now simplify this. Minus 10 plus 2 into 2, 4. 4 EI theta B divided by 4 plus 2 EI theta C divided by 4. So 2 1 2 2. Final value MBC is equal to minus 10 plus EI theta B plus EI theta C divided by 2. This is the equation number 3. Similarly, we will go for the MCB, for span MCB. So the formula is, again we need to apply this formula. We need to apply this formula in case of, so in case of BA we need to substitute the CB. In case of B, put C. In case of A, put B. So MCB is equal to MFCB plus 2EIL 2 theta C plus theta B minus 3 delta divided by L. So now substitute. MFCB value we got was plus 10 we got. So substitute this value. So 10 plus 2EI divided by L is 4, and theta C plus theta B, because both have the hinge support, there will be some value. Again this becomes 0. So now simplify this. MCB is equal to 10 plus 2 into 2, 4 EI theta C divided by 4 plus 2 EI theta B divided by 4. So simplify this. Finally it will come out as 10 plus EI theta C plus EI theta B divided by 2. Call it as equation number 4. Equation number 4. Similarly, we go for the span CD. For MCD, we need to apply this formula. In case of AB, we have to put CD. In case of A, substitute C. In case of B, put D. So MCD is equal to MFCD plus 2EI divided by L 2 theta C plus theta B minus 3 rho divided by L. So substitute all the value. MFCD value we got was, minus 26.6. Put this value, minus 26.6 plus 2 ei divided by L is 4 and 2 into theta c is hinged, it has some value, and theta d is fixed end, it has value is 0. Theta d at point D is having the fixed support, it means theta d becomes 0, it becomes 0. So MCD is equal to minus 26.6 plus multiply 2 into 2 4 and 4 will get cancelled, it come out as 2 ei theta c, call it as equation number 5. Similarly for MDC we have the formula, we have to put this formula. In case of BA we need to put DC. So let formula MF DC plus 2 ei divided by L 2 theta d plus theta c minus 3 rho divided by L. So MF DC value we got was 26.6. Put this value. So 26.6 plus 2 ei divided by L value is 4. 2 into 2 theta d is fixed and it becomes 0, and plus theta c is hinged support, it has some value, it becomes 0. So simplify it. So MDC is equal to 26.6 plus 2 1 ja 2 2 ja. So ei theta c divided by 2, call it as equation number 6. So this is our second step. Our second step is completed. So next is, our third step is applying the equilibrium condition. So this equilibrium equation is for point 3, but our beam has 4 points. So now what we have to do is, I will tell you. First take these 3 point A, B, C, these 3 point, and later hide this A, then take the B, C, D. I will show how. So first take point A, B, C. For this we have the equilibrium equation BA plus BC is equal to 0. For this case we have the equilibrium equation BA plus BC is equal to 0. So then we need to take these 3 point BCD. So for BCD we have the equilibrium equation CB plus CD is equal to 0. So for first we have the equilibrium equation MBA plus MBC is equal to 0 for these 3 points. So add this. So same thing applies for point BCD. So for this we have the again MCB plus MCD is equal to 0. So these are the equilibrium equation for this problem. So by using this, now we will see we need to apply these two equilibrium equation condition, and this is the second condition. When we got to the 4 points, we have to do like this. So now we will apply condition 1 and condition 2 both. We will go for both. So now we will see. So this is our first condition and this is our second condition. Now we will see one by one. So MBA value we got was 2.22 plus 4 ei theta divided by 3. Substitute this value. 2.22 plus 4 ei theta b divided by 3, and MBC value we got was minus 10 ei theta b, minus 10 plus ei theta b plus ei theta c divided by 2. So substitute this here. So minus 10 plus ei theta p plus ei theta c divided by 2 is equal to 0. So now simplify this. So by simplifying, it will come out as 4 by 3 plus 1 ei theta b plus 1 by 2 ei theta c is equal to minus 2.22 plus 10. So call it as equation number 1. So now similarly we'll go for the second condition. So MCB plus MCD is equal to 0. MCB value we got was 10 plus ei theta b plus ei theta c plus ei theta b divided by 2, and our MCD value we got was 26.6 plus ei theta c. Substitute these two value here. MCB 10 plus ei theta c plus ei theta b divided by 2 minus 26.6 plus ei theta c is equal to 0. So now simplify this, it will come out as 1 by 2 ei theta b plus 2 ei theta c is equal to minus 10 plus 26.6. Call it as equation number 2. So now what we have to do is we have to solve the equation number 1 and equation number 2 to get the ei theta b value as well as ei theta c value. So I will show now how to solve this. So mod 5 1. So our value is 4 by 3 plus 1. So substitute 4 divided by 3 plus 1, 4 divided by 3 plus 1, and plus 1 divided by 2, 1 divided by 2 minus 2.22 plus 10. So minus 2.22 plus 10. So here this equation is 1 by 2, 1 divided by 2 plus 2 plus minus 10 plus 26.6 minus 10 plus 26.6. So solve this. So the first value will be our ei theta b. So ei theta b we got 1.64. So write it here 1.64, and for ei theta b solve the. So our y value is the ei theta c value 7.88. So 7.88 is the value of ei theta c. This is how we have to calculate. So now what we have to do is, here our first step is to find out the final moment. To find out the final moment, we have to put our ei theta b and ei theta c value in our equation 1, 2, 3, 4, 5, 6 to get the final moment. So our equation m a b is, so now substitute our ei theta b and ei theta c value to get the final moment. We'll see for MAB, we have the equation minus 4.44 plus 2 into ei theta b value we got was 1.64 divided by 3. So simplifying, it will come out as minus 3.34 kilonewton meter. So for BA, 2.22 plus 4 into ei theta b value is 1.64 divided by 3. By simplifying, it will come out as 4.40 kilonewton meter. Similarly for BC, minus 10 plus AI theta B value is 1.64 plus AI theta value is AI theta C value is 7.88. So 7.88 divided by 2. Simplify it. It will come out as minus 4.42 kilonewton meter. Similarly for MCB, 10 plus EI theta C value is 7.88 plus 1.64 divided by 2. So it will come out as 18.7 kilonewton meter. For CD, minus 26.2 plus 7.88, it will come out as minus 18.72 kilonewton meter. Similarly for MDC, 26.6 plus 7.88 divided by 2, it will come out as 30.54 kilonewton meter. So this is how we calculate the final moment. So this is our step 4 is our completes here now. So step 4 is completed. Our next step is to find out the support reaction. The support reaction, I have drawn the span separately. For span AB, here the moment MAB, the value we got was, final moment value we got was minus 3.34, and MBA we got was 4.40. MAB we got was minus 3.34. It means it is anti-clockwise. We don't need to write here negative, because the symbol itself says it is negative. And our MBA value we got was plus 4.40, so it is clockwise. So now we'll find out the reactions. For that we need to apply the summation of moment about A is equal to 0 clockwise positive. So this is anti-clockwise, minus 3.34 plus it is clockwise 4.40 plus 1 point load is there, 10 into the distance of 1, so it is clockwise, and minus RB, it is rotates anti-clockwise, minus RB into at a distance of from here to here is 3 is equal to 0. So simplify this, it will come out as RB is equal to 3.68 kilonewton. So it is upward positive. So now we need to find the RA. For that, summation of all the vertical forces is equal to 0. Upward we need to take positive. Here RA and RB are upward, it is positive, and 1 point load is it is moving downward, it is negative. So RA plus RB, I will substitute directly value 3.68 minus point load is 10 is equal to 0. So by simplifying, our RA value will come out as 6.32 kilonewton. It is also positive, it means it is moving upward. So similarly we'll go for the span BC. For BC we have the MBC value, moment value we'll see. So we have the MBC value minus 4.42 and MCB value 18.7. So minus 4.42 and here positive 18.7. So now calculate the reactions. Summation of moment about B is equal to 0 clockwise positive, it is rotating anti-clockwise, so minus 4.40, it is positive, rotating 18.7 plus the point load is 20 at a distance of 2 meter, minus RT, it is anti-clockwise rotating, so minus RC into at a distance of 4 from here to here, 4 is equal to 0. So simplify this, our RC value will come out as 13.57 kilonewton. So it is also positive, it is moving upward. So now to find out the RP, summation of all the vertical force is equal to 0, upward positive. Here RB and RC are moving upward and the point load is moving downward, it is negative, and RB and RC will take the positive. So RB plus RC value we got was 13.57. 13.57 minus 20 is equal to 0. So RB value will come out as 6.43 kilonewton. It is also positive. Similarly, we'll go for the span CD. Fan CD. So value of moment value for MCD is equal to, so MCD value is minus 18.72 and MDC value is 30.54. So MCD value is negative, so it is rotating anti-clockwise 18.72 and it is clockwise, that is 30.54. So now simplify this. Summation of moment about C is equal to 0, clockwise positive, so it is anti-clockwise, so negative minus 18.72 plus this is clockwise rotating 30.54 plus 20 into UDL distance is 4 at a distance of L divided by 2. L by 2 means 2. 4 divided by 2 is 2 minus Hardy into this distance, Hardy into distance 4. So Hardy, it is anti-clockwise, Hardy into at distance of 4 is equal to 0. So simplify this, it will come out as Hardy is equal to 42.9 kilonewton. It is also upward positive. RD value, will go for the RC. Summation of all the vertical force is equal to 0. Upward we need to take positive. So here RC and RB are upward and UDL is downward. So RC plus our RD value we got was 42.9, UDL is downward. So 20 into at a distance of 4 is equal to 0. So simplify this, our RC value will come out as 37.1 kilonewton. It is also positive. So these are the reactions. Now we'll go for the find out in the final reactions. So for RA value we have only one. RA is equal to 6.32. So write it. So write here 6.32 kilonewton RA. And for RB we have the value here 6.43 and 3.68. So to get the final value we need to add 3.68 plus 6.43 to get the final reaction. 3.68 plus 6.43, it will come out as 10.11 kilonewton. So now for RC we have the value here 13.57 as well as 37.1. So to get the final we need to add these two. RC is 37.1 plus 13.57. It will come out as 50.67 kilonewton. So finally our RD for RD. So for RD we have only one value, that is 42.9. So write it here 42.9 kilonewton. So 9 kilonewton. This is our final reactions. So now, we got the final reactions. Now we'll go for the drawing of SFD and BMD. This is our last step. We'll see. So now we'll go for the last step, drawing of the BMD and SFD. So I have already drawn the pre-body diagram of the bending moment. For finding the maximum height of this, we have the formula WAB divided by L. So our W is 10, A is 1 and B is 2 divided by L is 3. So substitute all the value, it will come out as 6.66 the maximum height. And for this we have the formula WL divided by 4. This is L, WL divided by 4. Our load is 20 plus L is 4 divided by 4. It will come out as 20. So for parabola, to find out the maximum value, we have the WL square divided by 8. So W is 20, L is 4 divided by 8. Simplify, it will come out as 40. This is L square. So now we will go for the diagram of net bending moment diagram. So for net bending moment diagram, we, by using the value of final bending moments, will draw the net bending moment diagram. So MAB, so see here the first point is here A. So for point A, our value is minus 3.34. So we always need to see the first point. So for first point we have the value minus 3.34. It comes here. For MBA, again we need to see the first alphabet is B here. For B line here, MBA, we need to see the first alphabet is B here. For B, point B, we have the value 4.40. So for point B means it comes here. We have the value 4.40. So our 3.3 here, make it here. So 4.40 it comes here, little bit of higher. And for MBC we have the value minus 4.42. So here first letter is B, it comes on point B, minus 4.40. So this is our point B. It also comes here only. And our next is for point CB. The first point is C, it will come at the point C, 18.7. So 18.7 means it comes below 20, means it comes here, 18.7. So similarly for MCD, the first point is C here, minus 18.72 means it also comes here only. So our last is MDC, value is 30.54. So it comes at point D, it comes here, 30.54. Now join this line. So this is our net bending moment diagram. So if you want, you can shade it. So it will come like this. So this is our net bending moment diagram. So now we'll go for the, so before that one more thing I want to tell you. So our MAB value is minus 3.34. So minus 3.34, it also comes the above the axis. See here point A is, this is the neutral axis, this is the neutral axis. So point A, our minus value comes above the neutral axis, it means it comes here. And for positive also it comes above the neutral axis, means here only. For similarly point B also it comes above the neutral axis, negative value, and positive value also it comes above the neutral axis. And point C also it comes above the neutral axis. Similarly it will apply for the both the points same. So now we'll go for the shear force diagram. By using the value of these reactions, we'll draw the shear force diagram. So at point A, our RA reaction is 6.32. So 6.32 means it comes here, 6.32. And from here to here is nothing, it will come like this. So here one point load is coming downward. It means 6.32. 6.32 minus 10. If you do, it will come out as minus 3.68. Minus 3.68 means it will come down here. It will come here minus 3.68. From here to here is nothing. It will come straight. Again here reaction RB is there. So minus 3.68. It is moving upward means we need to add it plus 10.11. It will come out as 6.43. 6.43. It means it comes here 6.43, and from here to here is nothing. It will come straight. Here again and point load is acting. It is downward. We need to subtract minus 20. So it will come out as minus 13.57. So minus 13.57 means it comes here minus 13.57. So we don't need to this symbol, right? It will already shows the it is below the axis. We don't need to write here this negative sign, because this axis below the neutral axis, it already indicates the it is negative. So minus 13.57. So again here reaction RB is there. It is moving upward means we need to add it 50.67. It will come out as 37.1. 37.1 means it will come here 37.1. Here on UDL is there, the value comes here below the neutral axis. So now 37.1, we need to 37.1 minus 20 into at a distance of 4, the UDL is acting. No, we need to subtract this. It will come out as minus 42.9. So minus 42.9 means it will come down here. So the graph will be, so it will come like this. And again one reaction RD is acting here. We need to add it minus 42.9 plus 42.9. It will come out as 0. The finally this will touch the our axis. It means when it comes the value 0, whatever we have calculated till now is right. So this is how we draw the shear force and bending moment diagram. This is the shear force diagram. This is how we'll draw. This is the shear force diagram. So join this line. And if you like the video, like it, share it and subscribe for the more videos. Thank you for watching.